All right, we are going to create a hello world in Java, and you're going to wish that we were in Python after this, because Python is one of the simplest languages. It's the closest to English that I've worked in myself. Java, C++, JavaScript, you can go on and on and on. Those have all kinds of curly braces and all kinds of fancy stuff. So why is that? Well, Python was developed to be easy. That was part of its design specification. They wanted something that was easy to use. So Python handles in the background a lot of the stuff that with other languages we have to take care of. Okay, we already did this part. And there are some interactive chapters and there's some fundamental tutorials. It's a good idea to go through these. It will reinforce what we're doing in class. We are going to jump right down to, oh, how does Java work? Oh, sorry, I'm pointing at something, you can't see it. Why is nobody telling me that? So we've already done this. This is some extra material. I'd recommend doing the fundamentals. These are very short little W3 schools things that take maybe 3 minutes each. It helps reinforce what we're doing. What is the best way to learn something? Starts
To
with an
exercise
R.
it.
Repetition. Do it over and over again. What do athletes do before a game? Do they wait till 11:30 before the game to do their practice? Nope. They drill and they drill and they drill and they drill so they don't even have to think about it. Is anybody here an athlete? Are you an athlete, Jens? What do you play?
Baseball.
So you know what repetition is like. And it doesn't matter what you're learning, if you're playing an instrument, whatever, you have to repeat it till you don't even have to think about it. That's what we're after. So how does Java work? Well, actually, Java works a bit like Python. We compile our program to what's called bytecode, but that can't run on the computer directly. Can't talk to the operating system. We're not talking to the computer, we're talking to the operating system. So we have a runtime environment. With Python, we only have two pieces. Python is more of an interpreter than a compiler, so it doesn't run as fast as Java does. But they're improving Python so that it's using some of this same technology. I think we're at whatever version we're at, the next version is supposed to have more of this in there. So in this case, we get bytecode, which is not executable. We have to have the Java virtual machine, which is like the Python interpreter, to tell the operating system what we want. C++ talks directly to the operating system. So you can get all kinds of trouble with C++. Python and Java and many other languages are considered managed languages because they have safeguards in them. C++, no safeguards. So everything we do, everything we have, no matter how big or small the components are, let me stop here just for a second, Ignacio.
No problem.
No matter how complex they are or how small they are, doesn't matter. They all have some sort of input. So my little Pi in the aquaponics lab, what's its input? It's not working right now. What kind of input is it getting? Am I sitting over there typing things in? Where's it getting its input?
You are typing in inputs.
I was typing input to try to fix it. But where's all the input that was on the web page coming from? Does input have to be a keyboard?
Yeah.
Does it?
The input has to be what you type in.
So I'm saying, does it? Does that give you a sense that I'm saying that input can also be other things? Sensors?
Yeah.
That's input to your program.
Yep.
Many things can be input. Quite often we have input from the user. He's typing something in like I was doing with the Pi. This input is from the sensor and it's being uploaded automatically to a website called thingspeak.com and it's keeping a running record of what's happening. So far, so good. So input can be anything that's going into our program. Something is usually changed. Like the web stream is converted into like a stream, a bunch of little JPEG files, 10 JPEGs per second. So regular movies that we watch are 29 point something frames per second. The web server is doing 10 frames per second because we don't need it any faster because we don't have a lot of bandwidth. And we don't need, it is running at HD, but we have a bad connection. So process could also be add 1 and 1 equals 2. It could be print something to the screen. It could be I'm a web server. Do I have input on my web server in the back of the room? Yes. This is the input. I'm saying, show me the fishies, but they're not there. That's input. Input can be a request. It can be information. It can be lots of things. That's all input going into the program. And when I go to lab.wncc.edu, that is talking to my Internet Information Server, which is a web server on my server back there. There's two major web server platforms on the internet. Internet Information Server, because Microsoft owns half the world. Linux doesn't own any of the world, but they're very popular. Why?
It's open source.
Yeah, it's free. And the model that Linux people have used to make money is support. Because if you are Amazon and you lose $1 million a minute, you want people that know what they're doing. If you're a business like a hospital, you either have people on staff or you have somebody you can call to get things fixed now or people start dying. Here, if my fish cam is off for a while, what's the repercussions of that? Nothing really. I also put in a little video about our Cougar Creation Space. So this is a math club event. So we're going to have this in about 4 weeks. And there's Owen working on tier. He did a demo for my MATLAB class. Here's one of the engineering students installing a motor. All this stuff we're going to be doing. And this is when we're first figuring things out so we could get all the motors working because really the electronics we developed ourselves and all the code. So yeah, be cool. So everything has input, everything has process, everything has output. We're used to thinking of output as the console, aren't we? Well, the output could be a web page. The output could be a sensor reading being sent to someplace so that it's then displayed on the ThinkSpeak web page. So there's lots of different things that we can have as input, output, and process, but everything that I've talked about all uses the same thing. For instance, tier is run by a PS3 Bluetooth controller. There's our input. It goes to the Raspberry Pi. There's our process. It talks to the motor controller. It then outputs signals to the motors. Same thing, input, process, output. It's all the same. Now in Java, we get a lot more fussy. Python took care of all this for us. If we wanted to float, we typed in 7.1. We really only had to differentiate between floats and ints. Well, we're getting closer to the operating system, and Java and C++ are fussier. So now we have to pay attention to our data types. You'll be glad to know that primarily we'll use int and double to start with. Yeah, so same thing as Python, but look at all these other things. Yeah. So here we are, hello, well, look at all this. How many lines does it take to do this in Python? Yes, isn't that fun? So we're going to type this in and I'm going to explain it as we go. You're not going to understand everything and that's fine. We'll talk about it more as time goes on, what it is actually doing. So where's my program? Oh, I lost my Visual Studio Code. So the best way to work with Visual Studio Code is to open up File Explorer, find your folder, which I don't have one right now. Maybe I'll put it on here. No, I'll just put it on here. So in my documents, I'm going to make a Java folder for all my Java programs. If you haven't done this, a good time to do it. Don't have everything in one folder or you'll look for them. I am the have too many folders police. Inside here, I'm going to put a week 1. Inside of here, I'm going to put all my week 1 programs. And so I have, well, if I show you I don't have week 1 in my stuff. I have it organized by chapters because I've kind of written the book for this class. If I want to work on a project in week 1, Visual Studio Code creates a Java project on the fly in that folder. So if you just open up the file, you could have trouble. We want to open the folder. So in Windows 11, we right-click, go down to Show More Options. Is everybody following along? Are you following along?
No, we're just watching.
Oh, okay. There is a video of it. Go ahead and try to follow along. There it is. That opens the folder with code, which creates a project. Right now, we're going to have one file. Eventually, we'll have more than one. So I open that folder with code. And if you look down here, it's going to buzz and whir. Oh, it isn't going to buzz and whir yet because we haven't created a file yet. So now we're going to create a Java program called helloworld.java. Naming conventions in Java and C++ and Python are different. We want to use the standard naming conventions because that's what programmers are used to, and we want to be able to fit in with a team. So we're going to use the standard conventions. I'm going to click this little new file button. This is called camel casing. And Java likes this. Java is the extension which tells Visual Studio Code that this is a Java file. In Windows, we like extensions. And now, there, see at the bottom, it says Java activating extensions, blah, 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 blah. It's creating a little Java project. Plus, if we're looking at it like this, we can delete, we can work on different projects and move between them quickly. It's a pretty efficient way to work in Visual Studio Code. So far, so good. If not, let me know. Everybody good? Christy? Caleb, you're good? All right. Now, comments. Oh, yeah, I don't need to show shortcuts yet. There are shortcuts that'll fill in most of the program, but I'll show you later on. So, this is a single line comment. There. In Java and C++. There. See, it's trying to fill in everything for me. We don't learn much by doing that. Is yours filling in public class, blah, 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 blah? Okay, because I have a hard time turning off Copilot when I don't need it. And I don't need it right now. How do we turn it off? And they move the turn off thing to different places. Anyway, I'll just have to ignore it. So there's my comment. I press enter. That's a single line comment. You can see on the program, it has a multi-line comment, which is the same in C++. You do a slash and a star. And then to end it, you do a star and a slash. That's if you want multi-lines, which of course is different. So Python, Java, C++ all do the same thing. They have loops, they have variables, they have decision statements, they have all kinds of things. How you type it in is different, but the concept is the same. Python is object-oriented. Java is object-oriented, but we have to type it in. So does this mean the name of my class is Hello World? Yeah. In Java, this has to match the name of the file. Otherwise, you're going to have problemo after problemo. And everything gets enclosed in curly braces. In Python, we used indents. Java, we use curly braces. I am not going to go through this. I'm just going to say generally, every programming language has a part of the file that has a main. The main is where the operating system says, oh, this is what I need to execute. Python takes care of that for you if you don't put in your own main function. Java and C++ do not. You have to put in your main function. That tells the operating system this is a program that we want to do something with. That's the main part that you want to remember from there. This whole string arg business, yeah, we don't care about that. But this also has curly braces. And curly braces, guess what? Have to match. They open, they close. Are you wanting to go back to Python now?
Is there a possibility you could zoom in?
Oh, thank you. I forgot about that. Yes, there is a possibility. How's that? Thank you for asking. Yeah. So this is the container of our program. This is where our program starts. All programming language has some place where the program starts running. And this is where Java starts. And it's quite often called main. Python does main automatically if you don't put one in. Here's where we put our code. Well, in Java and C++, we're much closer to the operating system. There's not so much stuff handled for us. Python is a very friendly, helpful language. It tries to hold your hand the entire time, which makes it a good language for getting started with. But in the professional world, when you get a job doing things, you're not just going to be able to use Python. You're going to go to Microsoft and they're going to say, Python? We do C#. That's what we do. You go to work for somebody else, they're going to say, we do C++. Somebody else is going to do React. But what mostly happens is you go someplace, they're going to want you to work in 5 or 6 or 7 or 8, 10 languages, depending on what you're doing. That's why we're starting out an intro to computer science, learning 3 different languages. Because in the next step you go to university, I have no idea what you're going to end up programming in. Likely it's going to be Java, Python, or C++, or all 3. That's most likely, but you may not. So we're going to learn how to learn languages. So we have to say system. What does system refer to? The operating system. So we're saying to the operating system, okay, operating system, pay attention. Remember we talked about input and output? We have to say, we're going to go out. We're going out of the program. And then we're going to print, well, this one kind of says what it is. What does PRINTLN do, do you suppose? Print line. Yeah, that's what it means. So we're closer to the operating system than we are in Python. We have to do more work in this type of program. But what Python's doing in the background is a lot of this is this same stuff. So we put what we want to print in the parentheses, and just like Python and most languages, double quotes mean that a string is coming up. Hello, world. My fish can't swim. Whoops. And it can't. We just sent him off the edge of the cliff. And of course, you can put comments in here too. You can put comments wherever you want. I like comments. Is code that's written professionally commented? Depends. Like the source code for Java, oh yeah, there's way more comments than there is actually code. Source code for Python, way more comments than code. Source code for Arduino, same thing. Source code for C++. In some places, they don't have the comment thing like I do. I like comments and documentation. If I don't work on a program for like, if it's a month since I've worked on a program, I forget about it. I don't remember what I was thinking. Sometimes I don't remember what I'm thinking from one semester to the next. Now we got a little red squiggly. That means that Visual Studio Code doesn't like it. You may end up somewhere where you have to use an editor that has no help. And we'll do that. We'll use editors that have no help. Like in Linux, we'll use Nano. No help there. Every executable line in Java and C++ have to end with a semicolon. This is doing something. It's doing input or output or a calculation. This is not doing anything. This is not doing anything. This is creating the program. But this line is actually accomplishing something. That's the best divider I can tell you. And it matters. If you have one thing wrong, it doesn't work. If you have one thing wrong in Python, it doesn't work. But there's just a lot more stuff you have to do in Java to get things to work. So there's a lot more rooms for error. So I've been saving as I've gone with my Control S key. The more you can use your keyboard, the better. If you right click and do everything and click your mouse to do everything, I'm going to say, stay away from that mouse. Start learning shortcut keys. And I'll mention lots of them as we go. One of them, Control S. I don't even think about it. I've been doing Control S this whole time. And that's, in some respects, that's referred to as muscle memory. Well, it's not really your muscles that are memorizing it. Your neurons, the connections between your neurons have gotten very thick. It's like with Jens, his neurons of swinging a bat are very thick. My neurons of swinging a bat almost don't exist. I don't swing a bat very often, where you probably swing one every day a bunch of times. I'm just using that as an analogy. So literally, when you're repeating things every day, you're building up strength in your brain. If all you do is tell AI what to do, yeah, you're not building up any strength in your brain. It is a good tool, but it's only a tool.
I have a question, sir.
Sure, Eliza, what have you got?
Oh, okay.
So what learning more than one language does is it starts you thinking about how to solve the problem first. And we're going to work on that a lot more in computer science. How do you create the algorithm, which is a solution to a problem? All we do in IT is find solutions to problems. We troubleshoot, we fix things, we write programs, we change code. We're always solving problems. We're also adding features. We're also making it better. But fundamentally, the first thing we have to do is solve problems. Once the problems are solved, then we can make it nicer. And Owen spent all summer doing that at the Panhandle Station. First, they wanted it to work. Then they make it look pretty. That's a natural workflow in IT. You just want it to work, and then you can make it fancy. Computer science, cybersecurity, doesn't matter. It's the same stuff. Once you get out of the weeds and you can see all programming languages have input, process, and output. They all have loops. They all have variables. They all have decision statements. They all have objects. They all have all these things. All of these things are in common. So what you do is you say, the guy, somebody comes up and they give you a request, say, I want a program that can run on my cash register that keeps track of all my customers. Well, you're probably not going to use a web server in TypeScript, maybe. I don't know, you're going to have to pick the right tool for the job. If you're going to pound in a nail, you don't get your tape measure, do you? You get a hammer. So we're going to learn how to solve the problem first and pick the right tool and then implement it. Many people will just sit down and start coding. That's backwards. We want to design and figure out the problem first before we test it and see if it works. Make sense? That's what we're going to do a lot of in this class. The more you can comment and show me your thinking, the better. The more questions you ask, the better. Because then I know you're engaged in thinking about it. Anyway, I think we're at a good stopping place for today. If you can get Java up and running, get Hello World out, you've accomplished a lot. Now, then it's just a matter of creating more programs, which, yes, as Eliza asked, Java is one of the few languages where this has to match that. That's just a restriction on how Java works. The class name has to match the name of the file. Don't ask me. I didn't write the rules. Yes, I see you.
My last.
Nasi.
Yeah, am I allowed?
Are you allowed? No, I hate questions.
Oh, okay.
No, go ahead.
I just wanted to ask, like, how do you determine which language is based for the best project? Like, for example, for like a website or making another website that is.
Well, let's just use website as an example. If I'm creating a fishy website just for my students, I can use all kinds of different tools. I use Python just because it's easy.
Okay.
If I'm going to do an e-commerce website and I want to make sure it runs 24/7 and I want to service a lot of people, I want something that can run faster and is going to be more reliable.
Hmm.
So I would use probably Java. That's the one that's used in Linux servers. The language of Internet Information Server is C#, which is like Microsoft's version of Java. So it depends on your project. So what that's called is requirements. When you're doing a programming project or any kind of IT project, there's going to be requirements, meaning, and I have that in a lot of my directions. I'll say, these are the requirements. I'm not giving as many general things, but the requirement might be, this is a hobby website. You know, there's going to be maybe one person a day. That changes my requirements. It's going to be an e-commerce website. I might have 50,000 a day. That's a different solution. How do you know it's the best solution? After you learn and have enough tools, then you can start picking and choosing. Right now, everybody that's been in Python, their only tool is a hammer because they have Python. But that's what we're going to do in this class. We'll learn more tools, right? We'll have screwdrivers, we'll have tape measures, we'll learn SQL in this class, you know, which is every website you go to has structured query language. And what does SQL do for us? What kind of a language is it? Does anybody know?
SQL databases.
Databases, yeah. Jens is on top of it. Jens is on top of it. We're gonna learn some SQL because behind everything, behind this code is SQL manipulating a database. You don't go to anything that doesn't have a database. Well, if you go to my website, no, that's wrong, actually. I'm not running the SQL code, but all this stuff is stored in an SQL database on ThingSpeak. This was updated 3 minutes ago. What do you suppose that means, Owen? That means that this thing is connecting somehow. It connected. Because this wouldn't update. So I didn't break it. Yeah, I didn't break it. Maybe it's just the VNC because this won't update. That's why I kind of had this up looking at it. I thought, oh, this is on a 10-minute cycle. So in 10 minutes, I have it taking a sensor reading every 30 seconds. And then I'm averaging that. And then that gets posted to ThingSpeak every 10 minutes. So if this goes over 10 minutes, it's not communicating with the ThingSpeak website. So this means that it's doing something. So I didn't break it. That doesn't mean that the fishies are going to work. We may have to, we probably don't have enough bandwidth for that to work yet. But sensors, just a few little bytes, it's done. It just has to send 72.7. That's it. 7.69, 1 or 0. So sensor data takes nothing at all. Just a few little bytes. So it is sending little bytes, but it's just not doing the streaming. And there's maybe not enough bandwidth that I can get to it. And maybe it's also changed to DHCP. I don't know. But that's what I'll troubleshoot next. Anyway, we're done with class for today. I am going to run a scan on that network and see if I can find my Pi. I bet that's what it did.
So I have a question about the assignment for
We'll answer questions first. Owen is going to be our tutor. If you have questions in between, we'll have a schedule posted.
as part of a professional communication. If you
Yep.
did last semester, do you have to redo it or?
Sure.
Okay.
The more you do it, the more practice you get.
Okay, I'll just make it short.
Yeah, that's what we want to do is keep doing things again and again and again. See you later, Christy. We want to lift weights every day.
Thank you, appreciate it.
You're welcome.
Good day.
I have another question.
Sure.
So how, like, which like baseline like tests do like each language go through that you can like decide, okay, this is the best like shape for this. Like, for example, you were talking about like the e-commerce website. You said Java is best. What makes Java better than HTML, for example?
They're two different things. HTML, oh, I don't have a web page. So HTML. There we go. So it's over here. That's why I can't get it to come up. There we go. So HTML provides the framework to put all the text on the page. That's all it does. It's not a scripting language, it's nothing like that. How you make it look pretty is with CSS it's called cascading style sheets. One of the ways you make interactivity is with JavaScript. This interactivity on this website is done by the Flask web server, which is written in Python. So there's lots of little tools going.
See, actually, I think that was a bad question. I meant like, for example, making, okay, JavaScript and Python, like what makes each?
JavaScript is only for front-end interactivity and development. Python can be used for 50,000 things. Everything from putting a shuttle in orbit to Raspberry Pis, to websites, to scientific computing, calculating the end of the universe. It's used all kinds of places. There's even MicroPython that's used that's our motor controllers for TIR, use MicroPython. So our motor controllers are like little chips. So Python is a good general purpose language. It does all kinds of stuff.
All the phones.
Java isn't quite as general purpose. One of the things that makes Python very powerful is there's a huge open source community that makes extensions for Python. So Python has gazillions of, not the extensions in Visual Studio Code, they're called libraries. Yep, so I'm using a Flask library for this. I'm using a request library to send information. I can't remember what else I'm doing. I'm doing something that allows streaming to go through it. So it has lots of little helper programs, where in C++, you kind of have to write it yourself. And a lot of the things that you do in Python, somebody has done it for you. But is Python designed really for an industrial web server? No. Owen and I have crashed and burned this one quite a bit.
Oh,
That's why,
I saw the server yesterday.
so like Java.
No, it's not really the server, it's the streaming is kind of, and the server, the web server doesn't know what to do with it.
Not with my face, I.
That's why you were saying Java is more for more finesse than anything, or more finely tuned.
More efficiency.
More efficiency.
Yeah, it's more efficient, it's more reliable. Python is really, nobody really uses it for a high-end production server because Python just doesn't have the capacity maybe that Java does. But it's used for a lot for these little projects because it's a lot simpler to put together.
so like I can get like a bunch of like libraries and extensions on like GitHub open source type of.
Actually, we'll install some as we go through in Python in the class you're in. I usually install them on the command line. How you add libraries to Python is with the pip command. And I can't remember what pip stands for. Python installation something, I don't know, maybe it doesn't stand. Anyway, it's the manager of libraries for Python.
Oh, that's probably.
With Java, there's other libraries too, but not as many, and you have to manually put them in. Where Python was designed from the beginning, easily add stuff to it.
Stuff to that. See, that's interesting. Thank you.
Mhm.
I think I had more of like practical, not of the background of it or understood of it. Yeah.
Yeah, and if you work on some of our projects, we're implementing things in the real world. We're using Python. We're not doing Amazon style stuff, but still,
That's true.
we're putting our programming and everything else to work.
Well,
Well, that's funny.
See you later, Mr. Joe.
Is a recursive acronym.